So first thing, all of this stuff that we're doing today is not going to be, well, it's going to be directly used when we're using parallel and perpendicular lines. Okay? Eventually, we're going to classify polynomials. I'm not sorry, not polynomials. Polygons, such as quadrilaterals, triangles, whatever, and we're going to figure out what type of quadrilateral it is, what type of triangle it is, based off of what we know about parallel and perpendicular lines. That's what we're going to get to. Now, before we get to that, we have to review everything you guys did in algebra that involves lines. Okay? Now, with parallel and perpendicular lines, the two most important things that we need to review about parallel and perpendicular lines are about their slopes. I know I have a slide here. Here it is. Parallel lines, what do we know about the slopes of parallel lines? They are the same. What do we know about the slopes of perpendicular lines? They are opposites and they are reciprocals. Okay? So, if we know that the slope of a line is 3/4, then the slope of a line that is parallel is also 3/4. And the slope of a line that is perpendicular to that line is -4/3 because it's opposite, so it's negative, and the reciprocal is 4/3. Now, all of these notes are posted online, so if you don't want to write this part down, this is review from last week. Okay? -1/2. If it's parallel, it's also -1/2. We're talking about the slope. The reciprocal of -1/2, the opposite reciprocal, is +2, because 1/2 flips and becomes 2. -3, okay, -3 and 1/3. 5 and -1/5. Okay, -1 is -1, and then the reciprocal is +1. Okay, that's what we've been going over. Now, with all of that, we also have to review slope-intercept form. Okay, slope-intercept form is our most basic line when we learned in algebra how to graph lines. Okay, we learned about slope-intercept form. Y equals mx plus b. That is going to be our friend. Now, today we're going to learn about other forms of this y equals mx plus b. But talking about slope specifically, there are a couple different ways to look at slope. Okay, there's positive slope, which means that if you're reading it from left to right, it's going uphill, it's increasing. If it's going downhill, it's a negative slope. Okay, so we can see slope, positive and negative, based off just looking at a line. Is it going uphill and increasing? Is it going downhill and decreasing? Does that make sense to everybody? Now, you can also find slope based on an equation. If it's in slope-intercept form, we know right here our slope is 3. Our y-intercept is -2. And we can graph that. We can graph the y-intercept. We can count the rise over the run. Slope and rise over run are the same thing. Okay? Y-intercept, we talked about that the coordinates of the y-intercept, we call the y-intercept 5, but the coordinates would be 0, 5. If the y-intercept is -2, the coordinates would be 0, -2. Right? Then we've looked at all different forms of slope-intercept form. All right? Now, a couple things to be careful of, because some of us mix this up, especially when you're typing things in Khan Academy. All right? Are all three of those the same? All three of those slopes right there. Are they equivalent? Yes, they are. All right? The only thing that is wrong is that if you're going to use Khan Academy and you're going to type one in, this one right here is considered not simplified. Why is it not simplified? Very good. We don't like to, when we enter a fraction, we don't like to enter the fraction with a negative on the bottom of the fraction. All right? Either put it out in front or put it up top. Is it equivalent? Yes, but it's not simplified. Okay? Exciting stuff, I know. Now, another thing. If you have a slope of, let's say, 2/3 x, would everybody agree right here that our slope is 2/3? Okay? Now, is this the equivalent of that? Is that the same thing? Okay. Now, is x on top the same as x on the side? What about the negative on top and the negative on the side? This is also okay. The slope is still 2/3. That is fine. About this. Okay, is that the equivalent? No, it is not. All right, you cannot write the x on the bottom. The x can go to the side, the x can go on top, it cannot go on the bottom. It's different. We always put it usually to the right. Like, just like when we write 2x, we write it like this, we don't write it like this, right? Okay, so same thing with 2/3 x. You write it like that, we don't write it like that. Okay, yeah, it does look like times. Now, here is why this works out the way it is. Let's pick a number. Okay, for example, 6. If I were to enter 6 in place of x, what is 2/3 of 6? 4. Right? Let's say I entered it like this. Doesn't this say 2 times 6? 12 divided by 3, which is 4. Okay? If I did it over here, this says 3 times 6, which is 18. And is 2/18 the same as 4? No. Okay? That's why this way doesn't work out. The x can be to the side, it can be on top, it cannot be on bottom. All right? So just some clarification things there. Then we learned how to find slope from 2 points. And instead of calling it rise over run, because we can't see the rise, we can't see the run, we called it delta y over delta x, which means change in y over change in x. And from this y, -5, to that y, -2, is a change of going up 3. And from this x to that x is a change of -2. And so we simplify that and call it -3 over 2. We know how to find slope from 2 points. So if you have a picture, you can count rise over run. If you have 2 points, you can find the slope by counting change in y over change in x. Don't forget it's y over x, not x over y. Okay? All review stuff. Then we learned that if you can find the slope and you want to try and find slope-intercept form, which is y equals mx plus b, well, you can find the slope like we just did. From 1 to -4 is a change of -5, and from 6 to 4 is a change of down 2, and that means that our slope is 5 over 2. And then in order to find the y-intercept, what did we do? Plug it in, okay? Does it matter which one we plug in? No, okay? So you can put 6 right here in place of x, and then you can put 4, no, since I use 6, I have to use 1, okay? And then you simplify. This part right here gives me 15. Okay, this part over here is 1. 15 plus what gives me 1? -14. And so you can find slope-intercept form by finding the slope and then plugging in a point for x and y, and then that can give you slope-intercept form. All right? Now, this is everybody's most exciting part, is that when we realize that slope-intercept form is not all the fun you get to have with lines, okay? But rather, there are other forms of the line. Now, as we just saw, in slope-intercept form, we get this. And with slope-intercept form, this is the slope, and this is the y-intercept. Hence the name slope-intercept form. Okay? Now, standard form. Dig deep into those brains. Okay? In algebra, you learned about standard form as well, which is this. So remember standard form? Okay? And then there's also point slope form. Which is this. Yes. Calm down, Reese. You're very excited right now. More things to talk about at Christmas and Thanksgiving when you get together with family. Okay. Now, here's the frustrating part. Standard form. If it's in standard form, there's nothing that you can use from standard form. Okay? Nothing that you can use from standard form. Are you working? Okay. Sounds good. That's fine. All right. So if we're in standard form, you're going to have to convert it. So if you want to write that down, must convert. Now, in point slope form, this is your slope, just like slope intercept form. All right. And then this x1 and y1 represent an xy coordinate, which is your point. So this is a coordinate or a point that's on the line. Okay. Now, why the heck do we have to use this? Just because. All right. But let's take a look at this. Eventually, we're going to get to where we have these two special lines, horizontal and vertical lines. We'll come back to that. Okay. Are you guys ready for the next part? Everybody cool? Everybody's heart's beating out of their chest yet? Haley, is your heart still in your chest? Not beat it out of there? All right. Here's where this is going. You're going to be asked a question that looks like this. What do the following two equations represent? The same line, parallel lines, perpendicular lines, or lines that are intersecting but not perpendicular. Okay? This is how you're going to tell. Okay? First off, if the lines are parallel, we know that parallel lines have the same slope. Correct? However, if they're parallel, do they cross the y-axis at the same spot? No, because they're separated, right? So they have the same slope, but they have different y-intercepts. That's the first thing we need to know. Now, if they have the same slope and the same y-intercept, what do we know about them? They're stacked on top of each other, and they're the exact same line. Okay? So, there's parallel, and there's the same line. That's the first thing. Then, perpendicular lines. What do we know about perpendicular lines? Their slopes are opposite reciprocals. Okay? Also, something to note is that with the y-intercepts do not matter if we're talking about perpendicular lines. It doesn't matter if they're the same, different. It doesn't matter because they're going different directions. Right? And then if it's none of these, then we're just calling it intersecting lines that are not parallel. I'm sorry, not perpendicular. So that'd be none of the above. It's just two regular lines that intersect. Okay? Those are our four options. Now, if we go back real quick, if I am in standard form, can you tell in standard form what is the slope or what is the y-intercept? No, you cannot. Can you tell in slope-intercept form what the slope and what the y-intercept are? Yes. Can you tell in point slope form what the slope is? Can you tell what the y-intercept is? No. Okay? This guy right here is our best friend, the top one. All right? So what we're going to do is we're going to learn how to convert things into slope-intercept form. Okay? This right here, actually, let me show you this real quick. Actually, let me start up here. I've got an example. Okay. This is going to show us how to go from standard form to slope-intercept. This is going to help us out and do that. Now, got some examples over here. Okay. Remember, standard form looks like this. So if I have 2x plus 4y equals negative 12, does that look like that? See how there's a number in front of your x, there's a number in front of your y, and there's a number over there by itself. X and y are on the same side. Right, Olivia? Okay. We're going to take this and we're going to convert it into this. Now, notice over here, in order to have it in slope-intercept form, the key is to get y by itself. Okay? So I want to take this guy, and I want to get y by itself. Okay? So you are going to subtract 2x. Very good. Because that cancels out 2x, and I subtract 2x over here. And now I have 4y equals negative 2x minus 12. Does it matter which side I put the x on? No, but I'm trying to make it look like this guy over here, so I'm going to put it on the left and then the number by itself on the right. Now what do I need to do? Okay, divide by 4. Because in order to get y by itself, we've got to undo this 4. Now, here's something that we forget. You have to divide this by 4 and this by 4. You got to do both of them. Now, what does this simplify to? Negative 1/2. Okay, and what does this simplify to? Negative 3. And now that I'm in this form, I can compare it to this, and I know that my slope is negative 1/2, and I know that my y-intercept is negative 3. That is basic algebra, being able to convert it from standard form to slope-intercept form. Why do we put it in slope-intercept form? That way we can know what the slope is and what the y-intercept is. Okay? Now, I'm going to show you how to go from point-slope form to slope-intercept form. Is everybody okay with that? I know some of you aren't quite done writing, but I can come back if I need to. This is point-slope form converted to slope-intercept form. Point-slope form is this. And we're converting it again to that. Does everybody see how we have y with a number? We have a number out in front of the parentheses, and we have x with a number. Okay? So, in this situation, remember we're trying to get the y by itself. Okay? So what should I do first here? Okay? You could add 1 if you wanted, but the easiest thing to start out with is let's go ahead and distribute this. Okay? So I still have my y minus 1 over here. I have negative 1/2 times x, which is just negative 1/2 x. and I have negative a half times 8. What's a negative times a positive? Negative, and what's half of 8? 4. So I have that. Now what do? Add 1 to get y by itself. Okay, now when you add 1, it does not have to go to both parts. It only has to go to the number by itself. Different than multiplication and division. So I have negative 1/2 x minus 3. Now, if you take this and you write it over here, okay, it is the exact same. Our slope is negative a half, okay, and our y-intercept is negative 3. Now, this one that we started out with, would you have guessed it looking anything like this? No. Now, what do we know about this one and this one? Their slope is the same and their y-intercept is the same. Therefore, it is the same line. Okay, it doesn't look like the same line when we started, but it finished out to being the same line. All right, so if we quickly review, this right here, y equals negative 1/2 x minus 3, is the same as this right here, okay, which is also the same as this right here. There's lots of different ways to write the same line. All right, so what you're going to do is you're going to get something like this. 4x plus 2y equals 10. 4x minus 2y equals negative 10. And you're going to have to convert them to figure out if it's the same line, parallel lines, perpendicular lines, or just regular lines. All right? So we're going to take this guy, and we're going to convert it to slope-intercept form. What do I need to do first? Subtract 4x. Subtract 4x. Positive 2y equals negative 4x plus 10. Divide by 2. Don't forget you have to divide both terms by 2. Y equals negative 2x plus 5. Then I'm going to take my other one. Okay? Basically do the exact same thing, right? Subtract 4x. Negative 2y equals negative 4x minus 10. Did I write that correct? Yes. Okay. Then what? Divide by negative 2 everywhere. What is a negative divided by a negative? So it's positive 2x plus 5. Now, when you look at their slopes, are those the same? They're opposites, but are they reciprocals? No. So they don't have the same slope. They're definitely not the same line, right? Pretty close. Not quite, though. Okay? Distinct parallel lines. Do they have the same slope? No, it's not that. Okay? Do they have opposite reciprocals? No, they're opposites, but not reciprocals. Therefore, just regular intersecting lines. Distinct parallel lines. Same slope, different y-intercepts. Does everybody see how those could be confused, though, as something? Everybody's like, oh, they got to be something. They're really, really close to each other. But they're not. Okay. Now, one more example. I understand this is a long lesson. I apologize. Everybody ready? Okay. We've got these two lines. I'm going to rewrite it so you can see it a little bit better. What form is this? That is point slope. Okay. And yes, this is Standard form. Now, some people say that they can just look at this and automatically have the slope. Right? Because aren't we going to look at their slopes? Can I look at standard form and see the slope? No. All right? Some people like to go ahead and convert this to slope-intercept form and then convert this to slope-intercept form and just know I'm going to convert everything to slope-intercept form and then take a look at it. All right? So I'm going to do that real quick. So in this example, when I distribute this to both parts, I have negative 4x and negative times negative positive 8. Now, when I have to move this over, I need to subtract the 1 there, and I end up with y equals negative, y equals negative 4x, what's that give me? Plus 7. Okay. Now, here's my slope still, right? Which is the same as when I began. I'm going to convert this real quick, which we should be getting better at. Subtract 2x from both sides. Negative 8y equals negative 2x plus 16. Divide by negative 8. Okay. Y equals, what's a negative divided by negative? Positive. So that's going to give me 1/4 x minus 2. Okay. What is my slope here? 1/4. Now, if you look at negative 4 and positive 1/4, what do we need to know about them? They're opposite and reciprocals, therefore we have perpendicular lines. Now, did I need to convert this one to tell me that the slope was negative 4? No. Okay. Now, did I need to convert that one to come up with and say those are perpendicular? Well, I need to convert this one, but did I need to convert that one? I could have left this one the same and still got my answer perpendicular. Okay. However, if the slopes are the same, let's say that was a 1/4, and then you convert this one and you get 1/4. Now do I need to do something different? Yes, because now if I'm in this form, I don't know what the y-intercept is. So it could be same line or it could be distinct parallel lines, and then you might need to convert it. Does that make sense? Some people just like to convert everything to slope-intercept form and then take a look at it. That's fine. Sometimes you don't need to convert point-slope form because you've already got the slope and you might run into your perpendicular lines without doing that. Does that make sense to everybody? Okay. Now, your one assignment is this: parallel and perpendicular lines from equations. It's 4 questions, I'm pretty certain. Do it more than once, please. You might get 100 the first time through. Make sure you're doing it more than just one time. Okay? Don't forget to work on those worksheets if you're not done. We'll go over the answers on those tomorrow.